Today we're going to talk about changing from polar to rectangular and from rectangular to polar and all that fun stuff. Okay, so these notes are on the last two parts of Mrs. Hill's notes from yesterday or from the last video that you watched. So if you wanted to follow along there, if not, just take notes on this kind of stuff right here, and then the examples are just going to be real easy. So if you just wanted to follow along with those too. Okay, so I'm going to change this now back to just me. There we go. Hi everybody. Okay, so if we have a rectangular point, that means we just got a point sitting out here. It's got an x value, it's got a y value, x comma y. Yahoo for school, you've been doing it probably since middle school. Okay, what that means is you've got a specific x that you go out, and then you've got a specific y that you go up, and you get to it that way. Okay? Love it. Great, grand, and wonderful. Then you've got, so that's rectangular. Okay? So rectangular is x comma y. Okay? All right? Then you've also got polar. Polar is now saying that Superman is going to fly right to that point with a certain R value. On top of that, you've got an angle here that we'll call theta. We have to set the angle, and then we go out how far, and that tells us what we need to do. Okay? So polar is going to be in r comma theta mode. Okay? So how can we find those different things? Well, I'm going to be basing how to do the polar stuff, how to find r and how to find theta, based off of the rectangular stuff, and then I'm going to do the rectangular stuff based off of what you got in the polars. Okay? So my r value over here is going to be equal to the square root of x squared plus y squared. Because this is a right triangle, r value is the hypotenuse, so the Pythagorean theorem says r equals the square root of x squared plus y squared. Shabam. Done. Theta, well, I can actually find theta prime, my reference angle, by doing the inverse tangent of y over x. Okay? So we can do that, but we got to remember a couple of things that go along with that. First, we have to drop negatives. Feel that we've heard this once or twice or 50 times before. And the second thing is that this is my reference angle. So because it's my reference angle, that means then that if I'm in quadrant 1, my actual angle is my reference angle in quadrant number 1. In quadrant 2, my actual angle is 180 degrees minus my reference angle. In quadrant number 3, my actual angle is 180 degrees plus my reference angle. We've done all of those before. And in quadrant 4, my actual angle is 360 degrees minus my reference angle. Okay? So that's how we find theta and our r value. Okay? So we got to do a little maths to go along with it. Okay? Now, if I have a polar point and I want to find my rectangular point, well, then is just going to be r cosine of theta. Y is just going to be r sine of theta. That's it. That's how we switch over. It's maths that we've already done. Okay? So we're going to do these now. I got 6 examples that I'd like to do. I'm going to do like 3 of them, and then I'm going to give you some time to do the other 3. I'll put them up on the screen for you and all that fun stuff. Okay? So, oops, I got to go this way. So the first one is 3 comma pi over 2. Okay, so we've got 3 comma pi over 2. Switch back here. Okay, that I know is in polar form. I know that it's in polar form because I see that that is an angle. Okay, that tells me that that's an angle. If it's not as a known angle, then you're going to assume that it's in rectangular form. Okay, that's a known angle, pi over 2. So I need to put it into rectangular form. Okay, so this is going to be r cosine of theta, r sine of theta. So 3 cosine of pi over 2, 3 sine of pi over 2. Knowing what you know about angles, and you could type this in a calculator if you wanted to, just know that those are in radians, so make sure your calculator is in radians. Okay? But pi over 2, that's at 90 degrees, that's straight up on the unit circle, so cosine is equal to 0, and sine is equal to 1. So 3 times 0 is 0. 3 times 1 is 3. So my answer is the point, the rectangular point, 0, 3. These two, this polar one and this rectangular one, would get me to the exact same spot in space. Okay. Next one is, what was the next one? 3 comma pi over 6. Okay. Again, I know that this isn't polar because pi over 6 is an angle. So then this is going to be, again, r cosine of theta. So that's going to be 3 cosine of pi over 6, 3 sine of pi over 6. Okay. So out at pi over 6, the cosine value is the square root of 3 over 2, and the sine value is 1/2. Okay. So I need to multiply those two together. So then that would give me the rectangular point of 3 square roots of 3 over 2, and 3 times 1/2, which would just be 3 halves. Next one is, oops, let's get rid of those two. So the next one is square root of 3, comma 1. And then I'll just put the other one up there too right away. Negative 2, comma 2, or the next 2. Okay, so those are both in rectangular form because I don't know if this is an angle or if that is an angle. Okay, so those are both in rectangular form. I need to put them both into polar form. So first off, what I need to do is I need to find my r value. Well, that's going to be the square root of 3 squared plus 1 squared. Square root of 3 squared is 3. 1 squared is 1. So this is the square root of 4, which because r is going to be a distance, we're going to go with the principal root of 2. We're not going to do plus or minus there. We're going to go with just the principal ones because r is a distance. Okay? Then what I need to do is then I need to find my theta prime. Okay? And so that's going to be the inverse tangent of y over x. Okay? And so I can find that, and on the unit circle, that's going to be pi over 6. That actually gives me pi over 6. If I didn't want that, we could also go with inverse tangent of 1 divided by the square root of 3, and that gives me pi over 6 that way. Or on your calculator, it would also give you probably 30 degrees if your calculator is in degrees, not radians. Okay? So that gives me pi over 6 or 30 degrees. Okay? So this point is up in quadrant number 1. Positive square root of 3 over, positive 1 up over. So we're sitting up there in quadrant number 1. So that tells me then that theta is equal to theta prime in quadrant number 1. So the rectangular point is the square root 3 comma 1. The polar point would be 2 comma pi over 6 or 2 comma 30 degrees. And we would accept either one of those. Okay? Negative 2 comma positive 2. Again, find our r value. Negative 2 squared is 4. 2 squared is 4. So that's going to be the square root of 8, which I am going to simplify to be 2 square roots of 2. Okay. Pick my color. Inverse tangent of 2 over 2. I drop the negative sign. Okay. So this is asking me where is the inverse tangent or where is tangent equal to 1? So that's going to be at pi over 4 or 45 degrees. Okay. So then that point is in quadrant number 2. Negative 2, positive 2 is up there in quadrant number 2. Okay. So that means that my reference angle is 45 degrees or pi over 4. So my actual angle is going to be 180 degrees minus my reference angle. So pi minus pi over 4 is going to be 3 pi over 4, or 180 degrees minus 45 degrees is 135 degrees. So one of those two. Okay? So this answer over here would be the polar point 2 square roots of 2, comma 3 pi over 4, or 2 square roots of 2, comma 135 degrees. One of those two. Now the shadows are creeping in. See if... Oh, I don't think that's helping. Maybe that'll help just a little bit. Okay. All right. So there's those two. So now what I would like you to do is I would like you to pause the video and try these two examples on your own without me going through them. Try them, and it's one of each, and then restart the video, and I will have the explanations for you, or the worked outness on the back side. You get to watch me erase while you're pausing. All right, here we go. In 3, 2, 1, and shabam. There they are, okay? So first one, this is a polar. Okay? Because it is got an angle here, 5 pi over 8. That's an angle. So we need to take this one polar into rectangular. Okay? We'll just deal with that one first. Okay? So it's going to be R, not R equals. It's going to be R cosine of theta is going to be -2 cosine of 5 pi over 8. 5 pi over 8 is not on the unit circle. So what we have to do then is we have to go to this, and we can say -2 times the cosine of 5 pi over 8. And I can give the exact of it there. And so that is going to be 0.765. Then we'd have to do our sine of theta. So that would be -2 times the sine of 5 pi over 8. Again, we can go right to our calculator, and we can get -1.848, we'll call it. Okay. So those two combined give me my rectangular point of 0.765, -1.848 as my rectangular point for that one. Okay. Second one, this is rectangular. I need to take it into polar. So first I need to find my R value. So my R value is going to be the square root of -3 quantity squared plus -5 quantity squared. So that's 9 plus 25. 9 plus 25 is 34. So our value there is going to be the square root of 34. Then I need to find my reference angle, theta prime. That's going to be the inverse tangent of 5 divided by 3. Okay. Again, now we'll have to go to our calculators, and we'll have to go inverse tangent, where's trig? There's trig, inverse tangent of 5 divided by 3. Now mine is going to give it to us in radians, so I'm going to need to multiply that by 180 divided by pi. So that gives me a 59.036 reference angle. 0.036 degrees. Okay, so we've got a 59-degree reference angle there. So this is in negative, negative. That's in quadrant number 3. So my actual theta in quadrant number 3 is going to be 180 degrees plus my reference angle, or what's that going to be? 239.036 degrees. So my polar point for this particular -3, -5 rectangular point would be the square root of 34, 239.036 degrees is what you should have gotten there. Okay, that's it for today. There should be some videos after this from Mr. Roth on graphing polar functions. Have a great day.